Today, we're diving into a massive, and I mean massive, question in the energy world that most people never even think about: the big cleanup. What in the world happens when an oil well retires?
So, really think about it for a second. We hear all about drilling and production, but what happens when the pumps stop, when the well runs dry? You can't just walk away, right? There's a huge environmental and engineering legacy just sitting there, right under our feet.
All right, here's our game plan for today. We're going to look at what happens when a well's life is over, get the key terms down, walk through the 6-phase cleanup, see what else is involved, check out the rulebook, and then talk about why this all matters so much. Okay, let's jump right in. Every single oil and gas well out there has an expiration date, and the moment it stops producing, a whole new, incredibly complicated process kicks into gear. Yeah, you definitely can't just turn off the lights and lock the gate. These sites are complex industrial zones. If you just leave them, they can pose serious risks to the environment and public safety for, well, forever. That's why retiring them isn't just demolition. It's a super detailed engineering process designed to make them permanently safe. So to really get what's going on, we need to nail down 2 key terms. The whole process is called DNA, and it has 2 very distinct but totally connected parts. And here it is: Decommissioning and Abandonment, or DNA for short. This is the official, industry standard playbook for safely closing the book on any oil and gas asset for good. The best way to think about it is like this. Decommissioning is everything you can see up on the surface. It's like cleaning out an old factory. You cut the power, you clean the gear, you tear down the buildings. But abandonment, that's the really critical part. It's like performing permanent surgery, deep, deep underground, sealing the well with massive concrete plugs so that absolutely nothing can ever leak out. Okay, so let's walk through how this actually works. This isn't something that happens over a weekend. It's a careful 6-phase operation. It all kicks off with planning and engineering, sometimes years ahead of time. Then you've got prep work, getting everything clean and safe. After that comes the actual mechanical teardown, followed by the most crucial step: plugging that well deep underground. And finally, you have the full site cleanup and restoration, which can be so thorough you'd never even know an industrial site was there. Now here's where the scale of this thing really hits you. It's not just about that one well. The DNA process covers a huge network of stuff connected to it. I mean, we are talking about the whole shebang. Every pipeline, every storage tank, every pump, every building, and even the soil and water that might have gotten contaminated over the years. All of it has to be dealt with safely. For example, let's look at pipelines. First, they have to get every last drop of oil or gas out. They often do this with something called a pig. It's a device they shoot through the pipe to push everything out. Then the line is flushed clean before it's either dug up and removed or sealed and safely left in place, all according to very strict rules. And those facilities on the surface? Whoa, that's a massive industrial cleanup job. Every system has to be powered down, equipment gets taken apart, and all the waste, everything from scrap metal to some pretty nasty hazardous sludge, has to be carefully handled and disposed of properly. Now, as you can imagine, a process this complicated and this risky can't just be a free-for-all. It is governed by a super strict set of rules and standards to make sure everything is done safely and correctly. And this slide gives you a great idea of the layers of rules involved. You've got global best practices from organizations like the American Petroleum Institute, or API, but then on top of that, you have to follow all the specific national and local rules, like the examples you see here for Oman. You know, safety here is not an afterthought. It is built into every single action. Things like a permit-to-work system make sure every single job is reviewed for risks. Lockout-tagout procedures make it impossible for equipment to be turned on by accident. In this kind of high-stakes work, these safety controls are absolutely non-negotiable. So, after all this painstaking work, all the engineering, all the planning, what's the point? Why go to all this trouble? Well, let's talk about the payoff of a clean exit. First and foremost, it's about protecting our environment. It's that simple. When you properly plug an old well, you prevent oil, gas, or other nasty stuff from leaking into the soil and, most critically, into our groundwater. That's a huge deal. Second, it is all about keeping people safe for the long haul. A properly retired site eliminates the risk of old equipment collapsing, or worst-case scenario, a dangerous blowout. It makes the land safe for our kids and their kids, no matter how it's used in the future.
And finally, this isn't just about doing the right thing. It is a legal and financial must-do. Companies are required by law to do this work, and by doing it right, they get rid of the enormous financial risk of a future accident or being forced to pay for a cleanup later. It's just smart business to get it right the first time.
And all this brings us to one final, really big question. As the world's energy mix continues to shift, we have millions of wells around the globe that are getting older and older. The task ahead is just staggering. We have the playbook, we have the rules, but the real question is, are we actually prepared for what might just be the biggest cleanup in human history?